Okay, so today we will be talking about the development of the ventral and dorsal mesogastrium. Now, first of all, if we recollect the general embryology, we had done that the embryonic disc, when it has not yet folded, consists of three layers. The innermost of the ventral one is the endoderm. Then there is, let's give it a green color, there is the mesoderm, and then the overlying one is the ectoderm. Now this is before the folding. Suppose if this is the cranial end of the embryonic disc and this is the caudal end, and then eventually the head fold will form like this and the tail fold will form like this. What is this going to lead? This is going to transform the this endoderm into a cylindrical structure. Also, one more thing, remembering first initially that the endoderm uh, consisted of was continuous with this sac-like structure that was the yolk sac, right? Whereas if we also draw the another cavity was there above the embryo, that was the amniotic cavity, right? Okay. Now, when the head fold and the tail fold will form and the embryonic disc will fold like this, what will this lead to? This will lead to conversion of the endoderm from a flattened layer to this cylindrical structure which retains its communication with the yolk sac, right? And I'm not drawing the mesoderm and the ectoderm here now. Now these parts of the endodermal tube are called as the foregut. From here up to the this part, which is not communicating with the yolk sac directly. This part, which is communicating with the yolk sac directly, this part is called as the midgut, and the part caudal to it, this part is called as the hindgut. Right. Now we need to know what structures are derived from this foregut, midgut, and hindgut in the adult gastrointestinal tract. Now, if I draw the adult gastrointestinal tract, that includes what? There is the abdominal part of esophagus. I'm drawing only the parts which are present in the abdominopelvic cavity. Then we have the stomach, consists of the greater and the lesser curvatures. Then we have the duodenum. This is the first part of duodenum, the second part of duodenum, the third part of duodenum, the fourth part of duodenum, and then we have the coils of uh, jejunum like this. I will draw only a few coils, and then there are coils of ileum, right? Like this, and eventually ileum becomes continuous with the cecum, which also bears the appendix. Cecum becomes continuous with the ascending colon becomes continuous with the transverse colon becomes continuous with the descending colon becomes continuous with the sigmoid colon, and eventually the rectum and anal canal. Right. Now, out of these, which parts are derived from the number one foregut? So, the esophagus, the stomach, the first part of duodenum and second part of duodenum up to the level where the common bile duct and the pancreatic ducts open into the second part of duodenum. Up till here, this whole part is derived from the embryonic foregut, including esophagus, stomach, first part of duodenum, and proximal half of second part of duodenum. Right. Okay. Then, what is derived from the midgut? That includes this distal part of second part of duodenum, third part of duodenum, fourth part of duodenum, then the entire jejunum, the entire ileum, the cecum and appendix, and then we have the ascending colon, then the right two-third of the transverse colon up to here, to the junction of the right two-third and the left one-third of the transverse colon. Right. So up till here, the things are derived from the midgut, and finally, what is derived from the hindgut? This distal part, that is left one-third of transverse colon and the entire descending colon, sigmoid colon, rectum, and proximal part of the anal canal. These all are derived from the hindgut. Okay. Now, all this arrangement of the gastrointestinal tract within the abdominopelvic cavity develops after something called as rotation of gut that happens during the fetal life. Before that, just when the head and tail folds have happened, the gut tube is a straight tube. Now, if I draw a sagittal section through the body in which, let me just zoom into 100% level and let me draw this thing. If this is the, suppose this is the anterior abdominal wall, this is the posterior abdominal wall, this is the anterior aspect of body, this is the posterior aspect of body, this is the superior aspect, and this is the inferior aspect. So we have cut a sagittal section through the body, and if this uh, is my gut tube consisting of, suppose this much up till here is the foregut, then up till here is the midgut, and distal to it is the hindgut. Right. Now, how is this gut tube connected to the body walls? Now, uh, the foregut is connected to the anterior abdominal wall also, and to the posterior abdominal wall as well. Right. Right. Whereas the midgut and the hindgut, they are connected only to the posterior abdominal walls. Right. Okay. So the structure that connects the foregut to the anterior abdominal wall, this thing is called as ventral mesogastrium. Right. And similarly, this dorsal part up till this level, which connects the foregut to the posterior abdominal wall, this is called as the dorsal mesogastrium. Whereas this remaining part, structure from here up till here, which connects the midgut and hindgut to the posterior abdominal wall, this thing is called as the dorsal mesentery. Okay. Right. Now, what happens is that within the ventral mesogastrium, within this structure, develops what? The liver will develop. And within the dorsal mesogastrium, within this structure, develops the spleen. Right. And we also know that our foregut, this part of foregut present within the abdominal cavity is ultimately going to give rise to the stomach. It is going to become fusiform shaped, and the proximal part of duodenum as well. Right. So the development of liver within the ventral mesogastrium is going to divide the ventral mesogastrium into two parts. This number one is the ventral part, and number two is the dorsal part of ventral mesogastrium. And similarly, the development of spleen within this dorsal mesogastrium is going to divide the dorsal mesogastrium into two parts, a ventral part, which is number 3, and a dorsal part, which is number 4. So, ventral and dorsal parts of dorsal mesogastrium. Okay. So, we will cover them one by one. So, number 1 part, that is the ventral part of ventral mesogastrium. Now that stretches between what? It stretches between anterior abdominal wall and the liver. You have all been showed the structure. This is a sickle shaped fold of peritoneum connecting anterior abdominal wall with the anterior surface of liver. That is the falciform ligament. So ventral part of ventral mesogastrium will form the falciform ligament. Then number 2 is the dorsal part of ventral mesogastrium. This part, number 2. This is now stretching between the liver, and this would be which border of stomach? The anterior border of stomach, which in the future will form the lesser curvature. I will show you how it forms the lesser curvature. Now this structure, that is the dorsal part of ventral mesogastrium, it stretches between the liver and the lesser curvature of stomach. We all know that is going to form the lesser omentum. Then we come to the third part, that is the ventral part of the dorsal mesogastrium. We all know that stretches between this border of stomach, which is the posterior border before the rotation of stomach has happened, but after the rotation of stomach, this will become the left border of the stomach, which becomes the greater curvature. So this third part, that is the ventral part of dorsal mesogastrium, stretches between the greater curvature of stomach and spleen. That gives rise to the gastrosplenic ligament. Okay. However, the cranial part of the structure stretches between the greater curvature of stomach and the diaphragm. See, the abdominal cavity, roof of abdominal cavity is formed by the diaphragm. So the cranial most part of this ventral part of dorsal mesogastrium stretches between greater curvature and the diaphragm. The middle part stretches between greater curvature and spleen, and the caudal part that grows a lot to form something called as the greater omentum. So the ventral part of dorsal mesogastrium gives rise to three structures. Number 1 is the gastrophrenic ligament between the greater curvature and the diaphragm. Number 2 is this thing, the gastrosplenic ligament, and number 3 is the greater omentum. And finally, this number 4 structure, if I zoom out slightly, number 4, not here, I should write it, number 4, that is the dorsal part of dorsal mesogastrium, that stretches between what? Between the spleen and the posterior abdominal wall. That gives rise to the lienorenal ligament. Okay, because the left kidney lies on the left side of the posterior abdominal wall. So now we have done the four parts of the ventral and dorsal mesogastrium, that is two parts each of the ventral and dorsal mesogastrium. Remember this caudal free border of this dorsal part of ventral mesogastrium, this dorsal part of ventral mesogastrium which was forming the lesser omentum, this caudal free part in the adult will form the right free border of lesser omentum. Why? Because the stomach rotates around an anterior posterior axis also and around a superior inferior longitudinal axis also, and it is in this fold of peritoneum, the right free border of lesser omentum, that three very important structures travel, that is the proper hepatic artery, the portal vein, and the bile duct. Okay. Now what we will do is, let us cut a transverse section at this level, transverse section through the body at this level, and see what it will look like. Right? Let me zoom to 100% level, and then we will see. Now let us draw transverse section of the body such that this is anterior side of the body, this is posterior, this is right side of body, this is left side of body, so that we are looking at the transverse section from above. Now let me draw a section of the foregut here. Now the foregut has not yet rotated, and let me draw the parietal peritoneum which lines the inner aspect of the body walls, and let me draw the visceral peritoneum that comes like this, reflects from the anterior abdominal wall, covers the either surface of stomach, then reflects onto the posterior abdominal wall like this. Okay, right. Comes like this. Okay, right. So this is before the rotation of gut has happened. This is before any structures have developed in the ventral and the dorsal mesogastrium. Now you can guess this part will be called as what? This much part is the ventral mesogastrium and this much part is the dorsal mesogastrium, correct? Okay. Now within the this ventral mesogastrium, we remember that liver is going to develop. Okay. Within this, the liver is going to develop, whereas within the dorsal mesogastrium, the spleen is going to develop, and that is going to divide the ventral mesogastrium into two parts. This is number one part. This will be called as ventral part of ventral mesogastrium. This will be called as dorsal part of dorsal mesogastrium. Sorry, dorsal part of ventral mesogastrium, and then uh, this is the ventral part of dorsal mesogastrium, and this will be the dorsal part of dorsal mesogastrium. Right? Okay. Let me just remove these things. Okay. So, yeah. Okay. Now let me tell you how does the rotation of stomach happen around its longitudinal axis or its superior-inferior axis. Now initially before the rotation we call this as the anterior border of stomach. This is the posterior border of stomach, and this is the left surface of stomach, and this is the right surface of stomach. After a rotation will happen in a clockwise direction. If we look at it from above, remember that if we look at it from below, it will be happening in an anti-clockwise direction, but it is a convention to describe it as clockwise because we conventionally describe the rotation as if we are looking at it from a superior aspect, right? What is going to happen is that if I draw the similar section of the body, the stomach has become more or less like this, so that the anterior border has now become the right border of the stomach, and the posterior border has now become the left border of the stomach, whereas the left surface has now become the anterior surface of stomach and the right surface has now become the posterior surface of stomach. Okay, then the liver is going to develop somewhere here, and the spleen is going to displace uh, kind of slightly towards this side, and your left kidney would be lying somewhere here on the posterior abdominal wall. Okay. Similarly, the right kidney would be lying somewhere here. Right. Now let me first draw the parietal peritoneum, which lines obviously the inner aspect of the body wall. Okay. Then let me draw the visceral peritoneum. Number one, this ventral part of ventral mesogastrium still connects the anterior abdominal wall to the anterior surface of liver. This is the falciform liver. Then its left layer will go across the left side of liver, the right layer will go across the right surface of liver. Then these two layers will get reflected to the earlier, which was the anterior border of stomach. Now it has become the right border, and actually it has become the lesser curvature of stomach. So this structure will be forming the lesser omentum. Now this was the dorsal part of ventral mesogastrium. Then its anterior layer will go across the anterior surface of stomach, posterior layer will go across the posterior surface of stomach. These two layers will get reflected to the spleen, forming the ventral part of dorsal mesogastrium, that is the gastrosplenic ligament. Right. Then the anterior or the left layer of this gastrosplenic ligament will go cover the entire surface of spleen and will get reflected to the kidney. whereas the this posterior or the right layer of gastrosphenic ligament will directly go to the kidney. This the dorsal part of the dorsal mesogastrium is forming the lino-renal ligament. Lino refers to spleen, renal refers to the kidney, and then these two layers get reflected over the kidney and the posterior abdominal wall to become the parietal peritoneum like this. Okay, right. Okay, so we have again naming the structures. This is ventral part of ventral mesogastrium, which is giving rise to the falciform ligament. This is the dorsal part of ventral mesogastrium, which is giving rise to the lesser omentum. Please bear with my handwriting. Then this is the ventral part of dorsal mesogastrium, which is giving rise to the gastro splenic ligament. Why gastrosplenic? Because it is stretching between the stomach, specifically the greater curvature of stomach and the spleen. And then finally, this is the dorsal part of dorsal mesogastrium, which is forming our renal ligament. Right. And specifically, this part of the peritoneal cavity, which has now become limited to this much part, which has now, because of this clockwise rotation of stomach around its longitudinal axis, has come to lie behind the stomach. This now forms the lesser sac, right? Okay, now, and this is the remaining greater sac, right? These are all, this is the your this will eventually be called as the right subphrenic space. This is the left subphrenic space, right? This is your left subhepatic space, and this forms your lesser sac, whereas this the right subhepatic space, this forms something called as the hepatorenal pouch. Why hepatorenal pouch? You can see it lies between the posterior-inferior aspect of the liver and the right kidney. So this space is the hepatorenal space, and this communication between the two, this it I have shown it to be very wide, but it is not so wide, but this is narrow, via which the greater sac, specifically which part of greater sac? The hepatorenal pouch communicates with the lesser sac. This is your epiploic foramen, or it is also called as the foramen of Winslow. Right? Okay. So I think this much is enough for this. One more thing that I would like to tell you is another rotation of the stomach. Now, this rotation of the stomach, I have told you, this is happening around the longitudinal axis of the stomach. Now, if we again come to this diagram, the rotation that I've just told you about was happening around this axis. It was happening in which direction? It was kind of happening like this, in this direction, right? Another rotation that happens of the stomach, if immediately below it, if I again draw this gut tube in a spiro-inferior direction, this is the fusiform stomach that is forming, and then the duodenum and all. One axis that the across around which the rotation we have talked about is the longitudinal axis of the stomach, around which the rotation is happening in this way, right? So that the anterior border of the stomach goes towards the right side of body, and the posterior border of the stomach comes to lie towards the left side of the body. Another axis is around which the rotation of stomach happens is the antero-posterior axis. Okay, let me just complete these things. Right, now if this is yeah, I have rotated this diagram slightly, and if we consider this to be the anterior aspect of body, this to be the posterior aspect of body, another rotation that is going to happen is that will be in this direction, right? So that the uh, this lower end or the pyloric end of the stomach will shift towards the this right side of the body, and the proximal end will slightly shift towards the left side of the body. Right now, this has been reversed. This is the right side, and this is the left side of the body. This is slightly confusing for you guys. Right, if this is the anterior-posterior axis, then this should be my the patient's right side and the patient's or the subject's left side, right? So that is why, because of the rotation around this anterior-posterior axis, the lower end or the pyloric end of stomach shifts towards the right side, and the upper end or the cardiac end of the stomach shifts toward the left side. This leads to what? This will lead to what? Eventually, the stomach will assume its adult location. Now, this was initially the anterior border of the stomach, which has now come to lie towards the right side, thus forms the lesser curvature. This was initially the posterior border of stomach that has now come to lie towards the left side of the body. This has now formed the greater curvature. And why the greater curvature becomes longer and convex? Because there is greater growth along the fetal posterior border of the stomach. It grows much more in length as compared to this anterior border of the stomach. That is why the shape becomes like this. And because of rotation around this antero-posterior axis, the upper end of the stomach slightly goes towards the left side, and the lower end of stomach slightly goes towards the right side. So this junction lies slightly to the left side of the midline, whereas the pyloric end of stomach lies slightly towards the right side of midline. So this rotation is happening around an anterior-posterior axis. Whereas now this surface of stomach, which is visible to us, which is now the anterior surface of stomach, this was initially which surface of stomach? It was this left surface of stomach. But because of the rotation around this axis, the vertical axis, because of which the rotation, this surface, which was initially facing towards the left side, it now comes to face towards the anterior aspect, and now this forms the anterior surface of the stomach. So this anterior surface was actually the left surface of the stomach that has come anteriorly because of rotation around the longitudinal axis, right? So that's all.